Welcome everyone in this part.
Question number 101. 1 cubic meter of water weighs 1000 liters. Option D is the right answer. Question number 102. 1 liter of water occupies a volume of 10 to the power 3 centimeter cube. Option D is right answer. Question number 103. When a liquid is flowing through a pipe, the velocity of the liquid is maximum at the center and minimum near the walls. Option A is right answer. Question number 104. If an incompressible liquid is continuously flowing through a pipe, the quantity of liquid passing per second is different at different sections. False. Option B is right answer, because for an incompressible fluid whose density is constant throughout, the quantity of liquid passing per second will be same at different sections. Okay, so option B is right answer. Question number 105. The imaginary line drawn in the fluid in such a way that the tangent to any point gives the direction of the motion at that point is known as streamline. Option B is right answer. Streamline are a family of curves that are instantaneously tangent to the velocity vector of the flow. And streak lines. Streak lines are the loci of points of all the fluid particles that have continuously passed through a particular spatial point in the past. Next, path lines. Path lines are the trajectories that individual fluid particles follow. Question number 106. The flow in a pipe or channel is said to be uniform when the liquid particles at all sections have same velocities. Option A is right answer. That means del V divided by del X equal to 0. Question number 107. The flow in a pipe or channel is said to be non-uniform when the liquid particles at different sections have different velocities. Option B is right answer. The derivative of velocity with respect to direction is not equal to 0. Question number 108. A flow in which each liquid particle has a definite path and the paths of individual particles do not cross each other is called streamline flow. Option C is right answer. Question number 109. A flow in which each liquid particle does not have a definite path and the path of individual particles also cross each other is called turbulent flow. Option A is right answer. Agree. Question number 110. A flow in which the quantity of liquid flowing per second is constant is called steady flow. Option A is right answer. Question number 111. A flow in which the quantity of liquid flowing per second is not constant is called unsteady flow. Option D is right answer. Question number 112. Which of the following statement is correct? Option A. In a compressible flow, the volume of flowing liquid changes during the flow. Right. Option B. A flow in which the volume of flowing liquid does not change is called incompressible flow. Right. Option C. When the particles rotate about their own axis while flowing, the flow is said to be rotational flow. Right. So option D is the right answer. All of the above. Question number 113. According to the equation of continuity, option C is right answer. A1 V1 equal to A2 V2, where A is the cross sectional area and V is the velocity of that cross section. As per continuity equation, the discharge at different section will be same. A1 V1 equal to A2 V2 equal to AN VN. Question number 114. A flow through a long pipe at a constant rate is called steady uniform flow. Option A is right answer. Because the velocity is constant and the quantity of liquid passing through the pipe is constant, so the flow will be steady and uniform. So option A is right answer, steady and uniform flow. Question number 115. A flow through a long pipe at decreasing rate is called unsteady flow. Option B is right answer, because rate of flow decreases but remains same throughout the pipe. So the flow is changing with time but remains same across the cross section of the pipe. Question number 116. A flow through an expanding tube at constant rate is steady but non-uniform flow, because velocity is not constant but the quantity of liquid passing through the pipe is constant. So steady but non-uniform flow. Option B is right answer. Question number 117. A flow through an expanding tube at increasing rate is called unsteady non-uniform flow.
Option A is right answer. Yes, because rate of flow is varying with varying velocity.
Question number 118. A flow whose streamline is represented by a curve is called two-dimensional flow. Option B is right answer. Question number 109. A flow in which the volume of a fluid and its density does not change during the flow is called incompressible flow. Option A is right answer. Question number 120. All the gases are considered to have compressible flow and all the liquids are considered to have incompressible flow. Option A is right answer, correct. Question number 121. A flow whose streamline is represented by a straight line is called one dimensional flow. Option A is right answer. And a flow whose streamline is represented by a curve is called two dimensional flow, and the flow whose streamline is represented by space is known as three-dimensional flow. Question number 122. In one dimensional flow, the flow takes place in straight line. Option B is right answer. Question number 123. In two-dimensional flow, the flow does not take place in a curve. No, in two-dimensional flow, the flow takes place in a curve. So option B is right answer. False. Question number 124. The total energy of a liquid particle in motion is equal to pressure energy plus kinetic energy plus potential energy. Option A is right answer. Question number 125. The total head of a liquid particle in motion is equal to the pressure head plus kinetic head plus potential head. Option A is right answer. Question number 126. For a perfect incompressible liquid flowing in a continuous stream, the total energy of a particle remains the same while the particle moves from one point to another. This statement is called Bernoulli's equation. Option B is right answer. Question number 127. According to Bernoulli's equation, Z datum head Z plus P by W, that means
Pressure head,
plus P square by 2G, that means
velocity head.
equal to constant. Option A is right answer. Question number 128. Euler's equation in the differential form for motion of liquid is given by. Option A is right answer. dP by rho plus G into dZ plus V into dV equal to 0. dP by rho is the pressure gradient and G into dZ is the hydrostatic pressure gradient and V into dV is the acceleration of the fluid in motion. So option A is right answer. Question number 129. The Bernoulli's equation is based on the assumption that option A, there is no loss of energy of the liquid flowing, right? Option B, the velocity of flow is uniform across any cross section of the pipe, right? Option C, no force except gravity acts on the fluid, right? So option D is the right answer, all of the above. Question number 130. The Euler's equation for the motion of the liquid is based upon the assumption that option A, the fluid is non-viscous, homogeneous and incompressible, right? Option B, the velocity of flow is uniform over the section, right? Option C, the flow is continuous, steady and along the streamline, right? Option D is right answer, all of the above. Question number 131. Bernoulli's equation is applied to option A, venturi meter, option B, orifice meter, option C, pitot tube. Option D is right answer, all of this. Question number 132. Barometer is used to measure atmospheric pressure. Option B is right answer. Question number 133. The venturimeter is used to measure the discharge of liquid flowing in a pipe. Option C is right answer. Question number 134. The length of the divergent cone in a venturimeter is 3 to 4 times that of the convergent cone. Option C is right answer. Let me show you what is divergent cone and what is convergent cone in case of venturimeter. So option C is right answer. The length of the divergent cone in a venturimeter is 3 to 4 times of that of the convergent cone. Question number 135. In a venturimeter, the velocity of the liquid at the throat is higher than at inlet. Option A is right answer. Question number 136. The pressure of liquid at throat in a venturimeter is lower than that at inlet. Option B is right answer. Question number 137. The velocity of the liquid flowing through the divergent portion of a venturimeter decreases and area
increases. Question number 138. In order to avoid tendency of separation at the throat in a venturimeter, the ratio of the diameter at the throat to the diameter of the pipe should be 1 by 3 to 1 by 2. Option D is right answer. Question number 139. The pressure of the liquid flowing through the divergent portion of a venturimeter increases. Option B is right answer. Question number 140. The divergent portion of a venturimeter is made longer than the convergent portion in order to avoid the tendency of breaking away the stream of the liquid and to minimize the frictional losses. Option C is right answer, both A and B. Question number 141. The discharge through a venturimeter is given by. Option B is right answer, CD into A1 into A2 divided by root over of A1 square minus A2 square into root over 2gh, which is the velocity, where CD is the coefficient of discharge, A1 is the area at inlet, A2 is the area at the throat, and H is the venturi head. Question number 142. In order to measure the flow with a venturimeter, it is installed in. Option D is right answer, any direction and any location. Option D is right answer. Question number 143. A pitot tube is used to measure the velocity of flow at the required point in a pipe. Option A is right answer. Question number 144. When the venturimeter is inclined, then for a given flow it will show same reading. Option A is right answer, because it does not matter how it is placed. Question number 145. If a pitot tube is placed with its nose upstream, downstream or sideways, the reading will be the same in every case. No. Option B is right answer, false. Because when the nose of the pitot tube is towards the flow, there is a rise in the height of the tube by v square by 2g, that is kinetic head, and if the nose is facing downstream, there is a fall in the tube by a height of kinetic head v square by 2g. So the reading will not be same in both cases. Option B is right answer, false. Question number 146. The coefficient of contraction is the ratio of area of jet at vena contacta to the area of the orifice. Option D is the right answer. Suppose this is the jet of water through the orifice. So the minimum cross sectional area of the jet is called vena contracta. Okay. So coefficient of contraction is the ratio of area of jet at vena contracta to the area of the orifice. Option D is the right answer. Question number 147. Coefficient of resistance is the ratio of loss of head in the orifice to the head of water available at the exit of the orifice. Option C is right answer. Question number 148. A jet of water discharging from a 40 mm diameter orifice has a diameter of 32 mm at its vena contracta. The coefficient of contraction is. We know the formula for coefficient of contraction is equal to area of the jet at vena contracta to the area of the orifice. So area of jet at vena contracta will be pi by 4 into d equal to 32 mm. So area of jet at vena contracta will be pi by 4 into 32 square divided by area of the orifice, that means pi by 4 into 40 square. If we calculate, the coefficient of contraction will be 0.64. Option B is right answer. Question number 149. The coefficient of discharge is the ratio of theoretical discharge to the actual discharge through an orifice. No. Coefficient of discharge is the ratio of actual discharge divided by theoretical discharge. Option B is right answer, false. Question number 150. Coefficient of velocity is defined as the ratio of actual velocity of jet at vena contracta to the theoretical velocity. Option A is right answer. Question number 151. The theoretical velocity of jet at vena contracta is root over 2gh. Option D is right answer, root over 2gh, where h is the head of water at vena contracta. Question number 152. Coefficient of discharge CD is equal to CC into CV. Option A is right answer. CC is the coefficient of contraction and CV is the coefficient of velocity. Question number 153. An average value of coefficient of velocity is 0.95 to 0.99. So option D is the right answer. Question number 154. The value of coefficient of velocity for a sharp edge orifice decreases with the head of water, because we know the formula for coefficient of velocity equal to root over of x square divided by 4 into h into y. H is the head of water. So if the head increases, the value decreases. Option A is right answer. Question number 155. The value of coefficient of discharge is less than the value of coefficient of velocity. Option A is right answer. Question number 156. The coefficient of velocity is determined experimentally by using the relation. Option B is right answer. Coefficient of velocity CB equal to root over of x square divided by 4yh. Question number 157. Which of the following statement is wrong? Option A flow whose streamline is represented by a curve is called two-dimensional flow. Right. Option B, the total energy of a liquid particle is the sum of potential energy, kinetic energy and pressure energy. Right. Option C, the length of the divergent portion in a venturimeter is equal to the convergent portion. No, this divergent portion length is 2 to 3 times more than the convergent portion. So option C is the wrong. And option D, a pitot tube is used to measure the velocity of flow at the record point in a pipe. Right. So option C is the right answer for this question, because this is wrong. Question number 158. An orifice is said to be large if the available head of liquid is less than 5 times the height of the orifice. Option D is right answer. Question number 159. The velocity of liquid flowing through an orifice varies with the available head of the liquid. Option A is right answer. Agree. Question number 160. The discharge through a small rectangular orifice is given by. Option A is right answer. Q. Discharge Q equal to CD into A into root over 2GH, where CD is the coefficient of discharge for the orifice, A is the cross-sectional area of the orifice, and H is the height of the liquid above the center of the orifice. Question number 161. The discharge through a large rectangular orifice is given by. Option C is right answer. Q equal to 2 by 3 into CD into B root over 2G into within bracket H2 to the power 3 by 2 minus H1 to the power 3 by 2, where H1 is the height of the liquid above the top of the orifice, H2 is the height of the liquid above the bottom of the orifice, and B is the breadth of the orifice, and CD is the coefficient of discharge. Question number 162. The discharge through a wholly drowned orifice or submerged orifice is given by. Option C is right answer. Q equal to CD into B into within bracket H2 minus H1 into root over 2GH, where H1 is the height of water on the upstream side above the top of the orifice, and H2 is the height of water on the downstream side above the bottom of the orifice, and H is the difference between two water levels on either side of the orifice. Question number 163. A tank of uniform cross-sectional area A containing liquid up to height H1 has an orifice of cross-sectional area A at its bottom. The time required to bring the liquid level from H1 to H2 will be. So suppose this is a tank of uniform cross-sectional area which is capital A, ঠিক আছে, তারপরে liquid up to height H1, up to height H1 liquid is filled, and the orifice that is here at the bottom of area small a. Okay, so now consider a strip of thickness dh. Okay, that is the change of height in dt time. Okay, so if we equal this volume dh into area of this container, so equaling the volume of water through orifice, through this orifice, and the through this strip. So now consider the volume here, dh into area of this container, dh into area of this container, and which is equal to the volume of through passing through the orifice. Okay, and that will be equal to the discharge formula of this orifice, CD into root over 2gh into a, and the time dt, that is dt. So if we integrate the equation, we will get time t equal to 2 into a within bracket root over h1 minus h2 divided by cd into a into root over 2g. And if the tank is emptied, the h2, the value of h2 will be 0, and the value of final time that is required to empty the tank will be t equal to 2 into a, 2 into a root over h1 divided by cd into a into root over 2g. That is the equation. Okay, option C is right answer. 2 into A within bracket root over of H1 minus root over of H2 divided by CD into A into root over 2G. Question number 164. A tank of uniform cross-sectional area A containing liquid up to height H1 has an orifice of cross-sectional area A at its bottom. The time required to empty the tank completely will be. Option A is right answer. 2 into A root over H1 divided by CD into A into root over 2G. Question number 165. If the value of coefficient of discharge increases, the discharge through the orifice decreases. No. Option B is right answer. False. Because if the value of coefficient of discharge increases, the discharge through the orifice will increase. Question number 166. A hemispherical tank of radius r containing liquid up to height h1 has an orifice of cross-sectional area A at its bottom. The time required to lower the level of liquid from h1 to h2 will be. Option C is right answer. 2 pi divided by CD into A root over 2G within bracket 2/3 r square into h1 to the power 3 by 2 minus h2 to the power 3 by 2 minus 1 by 5 within bracket h1 to the power 5 by 2 minus h2 to the power 5 by 2 bracket close. So friends, this is the hemispherical tank of radius r and containing liquid up to height h1 and area of the orifice small a which is connected at the bottom of the tank. Okay, so let at any instant of time height of the liquid over the orifice is h and x be the radius of the liquid. Okay, so this distance is x. Okay, and this liquid surface is dh. Okay, this is liquid surface, so area of the liquid surface will be pi x square. Okay, now if we consider let a height of liquid decreases by dh in a small interval of time dt. Okay, so volume of the tank leaving the tank in time dt will be pi x square into dh. Okay, pi x square area and this thickness dh. Okay, this is equation 1. Consider now also volume of water by the orifice in time dt, that is coming out, that is coming down from the tank. Okay, that will be discharge for this orifice into time dt. So discharge will be cd into a into root over 2gh into dt, that will be equation number 2. Okay, so both equation will be equal to each other. We equaling equation 1 equal to equation 2, but this negative sign is required to indicate the flow is downward. Okay, so if we calculate, the dt will be minus pi x square by dh minus pi x square into dh divided by cd into a into root over 2gh. Okay, now consider from this figure x will be equal to root over of minus r square minus r minus h square x from the geometry. Okay, so x square will be 2rh minus h square. Okay, so if we put the value of x square here, we will get this equation, finally this equation. Okay, now if we integrate from lower limit to upper limit, okay, like dt 0 to t and this equation from h1 to h2. Okay, so we will get time t equal to 2 pi by cd into a into root over 2g within bracket 2/3 r into h1 to the power 3 by 2 minus h2 to the power 3 by 2 minus 1 by 5 within bracket h1 to the power 5 by 2 minus h2 to the power 5 by 2. Okay, and if we, and for empty tank h2 will be 0 because in this tank this level is h2. Okay, and if the tank is empty, the h2 value will be 0. Okay, so if we put h2 equal to 0, the equation will be 2 pi by cd into a into root over 2g within bracket 2/3 r into h1 3 over 3 by 2 minus 1 by 5 into h1 to the power 5 by 2. Okay, now look friends, if in this hemispherical tank h1, the height of liquid surface h1 is equal to r. Okay, and h1 will be equal to r in this hemispherical tank.
Okay, so if we put H1 equal to R into this equation, we will get the time required to completely empty the tank will be T equal to 14 pi into R to the power 5 by 2 divided by 15 CD into A into root over 2G. Okay, if we put H1 equal to R, which is the radius of the hemispherical tank. Okay, so in this way derivation is done. Okay, similar procedure is adopted like in case of uniform cross sectional area tank.
Question number 167. A hemispherical tank of radius r has an orifice of cross-sectional area A at its bottom and is full of liquid. The time required to empty the tank completely is. Option C is right answer. 14 pi r to the power 5 by 2 divided by 15 CD into A into root over 2G. Option C is right answer. Question number 168. A pipe of length more than double the diameter of the orifice fitted externally or internally to the orifice is called a mouthpiece. Option C is right answer. We know what is orifice. Orifice is the small opening in the side or bottom of a tank or vessel. Okay, and the pipe of length more than double the diameter of the orifice fitted externally or internally to the orifice is called mouthpiece. That is used to increase the amount of discharge through the orifice. And next, notch. A notch may be defined as an opening in one side of a tank or vessel with the upstream liquid level below the top of the edge of the opening. Next, wear. A wear may be defined as regular obstruction in an open channel over which water flows. A nozzle is a narrow tube or pipe of varying cross-sectional area used to control the rate of flow of fluid when it leaves the pipe. Question number 169. In a short cylindrical external mouthpiece, the vena contracta occurs at a distance 1/4 the diameter of the orifice from the outer of the orifice. Option B is right answer. Question number 170. The length AB of a pipe ABC in which the liquid is flowing has a diameter D1 and is suddenly enlarged to diameter D2 at B, which is constant for the length BC. The loss of head due to sudden enlargement is. Option C is right answer. V1 minus V2 whole square divided by 2G. Question number 171. The length AB of a pipe ABC in which the liquid is flowing has a diameter D1 and is suddenly contracted to diameter D2 at B, which is constant through the length BC. The loss of head due to sudden contraction, assuming coefficient of contraction as 0.62 is. We know the loss of head due to sudden contraction is equal to V2 square divided by 2G within bracket 1 minus CC minus 1 to the power whole square. So if we put the value into the equation, we will get the value of loss of a head due to sudden contraction equal to 0.375 V2 square divided by 2G. Option D is right answer. Question number 172. The loss of head at entrance in a pipe is 0.5 V square divided by 2G, where V is the velocity of liquid in the pipe. Option B is right answer. Question number 173. The loss of head due to an obstruction in a pipe is twice the loss of head at its entrance. Option A is right answer. Agree. Question number 174. The loss of head at the exit in a pipe is V square by 2G. Option A is right answer. Question number 175. The discharge through an external mouthpiece is given by Q equal to 0.855 A into root over 2G H, where A is the cross-sectional area of the mouthpiece and H is the height of the liquid above the mouthpiece. Option A is right answer. Question number 176. The coefficient of discharge for an external mouthpiece depends upon length of the mouthpiece. Option D is right answer. Question number 177. Re-entrant or border's mouthpiece is an internal mouthpiece. Option A is right answer. Question number 178. In an internal mouthpiece, if the jet after contraction does not touch the sides of the mouthpiece, then the mouthpiece is said to be running free. Option B is right answer. And if the jet after contraction expands and fill the whole mouthpiece, then it is called mouthpiece running full. Question number 179. In an internal mouthpiece, if the jet after contraction expands and fills up the whole mouthpiece, then the mouthpiece is said to be running free. No, then the mouthpiece is said to be running full. Option B is right answer. False. Question number 180. An internal mouthpiece is said to be running full if the length of the mouthpiece is more than the 3 times the diameter of the orifice. Option C is right answer. Question number 181. The coefficient of discharge in case of internal mouthpiece is less than that of external mouthpiece. Question number 182. The coefficient of discharge for an external mouthpiece is 0.855. Option D is right answer. Question number 183. An internal mouthpiece is said to be running free if the length of the mouthpiece is less than the 3 times diameter of the orifice. Question number 184. When an internal mouthpiece is running free, the discharge through the mouthpiece is given by. Option A is right answer. Q equal to 0.5 into A root over 2GH, where A is the area of the mouthpiece and H is the height of the liquid above the mouthpiece. Question number 185. When an internal mouthpiece is running full, the discharge through the mouthpiece is twice the discharge when it is running free. No. Wrong. Option B is right answer. Question number 186. The discharge through a convergent mouthpiece is double the discharge through an internal mouthpiece of same diameter and head of water. Option D is right answer. Question number 187. In an external mouthpiece, an absolute pressure head at vena contractor is less than the atmospheric pressure head by an amount equal to 0.89 times the height of the liquid above the vena contractor. Question number 188. In an internal mouthpiece, the absolute pressure head at vena contracta is less than the atmospheric pressure head by an amount equal to height of the liquid above the vena contracta. Option A is right answer. Question number 189. In an external or internal mouthpiece, the absolute pressure head at vena contracta is 0 when atmospheric pressure head is 10.3 meter of water. Option A is right answer. Correct. Question number 190. In a convergent mouthpiece, the absolute pressure head at vena contracta is the same as that of atmosphere. True. Option A is right answer. True. Question number 191. In a convergent divergent mouthpiece, the ratio of area at outlet divergence and at vena contracta convergence of the mouthpiece is. Option C is right answer. A by AC equal to within bracket root over of 1 plus HA minus AC divided by H, where A and AC is the area of mouthpiece at outlet and vena contracta respectively. HA is the atmospheric pressure head and HC is the absolute pressure head at vena contracta, and H is the height of liquid above the mouthpiece. Question number 192. An opening in the side of a tank or vessel such that the liquid surface with the tank is below the top edge of the opening is known as notch. Option B is right answer. Question number 193. A notch is usually made of a metallic plate. Option A is right answer. Correct. Question number 194. A notch is used to measure the discharge of liquids. Option B is right answer. Question number 195. The discharge over a rectangular notch is. Option C is right answer. Q equal to 2 by 3 CD into B into root over 2G into H to the power 3 by 2, where B is the width of the notch and H is the height of the liquid above the seal of the notch. Question number 196. The discharge over a right angle notch is. Option D is right answer. Q equal to H by 15 CD into root over 2G into H to the power 5 by 2. Option D is right answer, where H is the height of the liquid above the apex of the notch. Question number 197. If the coefficient of discharge is 0.6, then the discharge over a right angle notch is. We know the formula for discharge of a right angle notch equal to H by 15 into CD into root over 2G into H to the power 5 by 2. Just put G equal to 10 meter per second square, acceleration due to gravity, and coefficient of discharge CD equal to 0.6 into the equation. If we calculate the value, the discharge over a right angle notch will be 1.417 into H to the power 5 by 2. Option B is right answer. Question number 198. The discharge over a rectangular notch is. Option B is right answer. Directly proportional to H to the power 3 by 2, where H is the head of the liquid above the seal of the notch. Question number 199. The discharge over a triangular notch is directly proportional to H to the power 5 by 2. Option D is right answer, because we know the formula for a triangular notch equal to 8 by 15 into CD into root over 2G into h to the power 5/2. Question number 200. The discharge over a trapezoidal notch is equal to the discharge over the rectangular notch plus discharge over the triangular notch. Option A is right answer.